Hi guys. Sorry I forgot to totally post today's lesson. Um so I'm kind of doing it late, but it was a really simple lesson. The lesson that we're doing today is 2.2 pure substances. And the thing you always have to remember about this, if you start looking at this picture, well, you have probably seen this picture before. You buy some fruit and then you leave it a little too long, and all of a sudden it starts to grow this mold everywhere. Okay. Um what so basically you have to just remember that everything is made of matter, and eventually everything will go undergo some type of change, especially if it's a fruit or a vegetable. But if you don't know what something is, you're definitely not going to eat it, right? So, because especially something like this will make you sick, right? So, nobody wants that. Now, today's topic is a real simple topic. It's known as pure substances. First off, they start by giving you examples of silver and table salt, those being two examples of chemical substances. Okay. The definition that they start with is: a substance is a matter that has uniform and definite composition. So first off, let's talk about uniform composition. So uniform means that it's gonna look all the same. Okay. Like I always like to think of when the band is on the football field during the halftime show, and all of a sudden, you're trying to find your friend. You can't really find them unless you actually know what instrument and all that good stuff, right? You know that she's short, you know that he's tall, big, small, whatever it is, right? So just think of uniform looking, there is everybody looks the same. Your substances, whatever it is, it looks the same, okay? When it comes to definite composition, what I always like to think of as definite composition is it has a specific formula. For example, H2O. H2O is water. We know that water has two hydrogens and one oxygen. Now, if we change the formula from H2O2, well, that's a completely different compound, okay? They may look the same in a glass bottle or in a beaker, but for the most part, they are completely different, okay? All samples of substances are also known as pure substances and have identical properties. When chemists are always running a chemical reaction, we want to always make sure that there are pure materials. Okay. Why do we want pure materials? Because we want to make sure that the reaction that we are trying to achieve won't have any surprises, right? If you have an impure reactant, well, something unexpected might happen where maybe a will be released that you never thought was going to happen. And this just causes problems in the long run, right? So we want to kind of avoid that by making sure that the materials we use are known as pure substances. One of the characteristics of a substance is that you always have to remember it cannot be separated into components by physical separation techniques. Now, what do I mean by that? Physical separation techniques can be, well, you have to remember yesterday's simulation where we talked about the pot of boiling water. If you were to drop some salt before boiling that water, you would think that the salt is, mixing with the water chemically, okay? When in reality, it is not, okay? If I were to put that pot over the fire and eventually boil off all the water, I would be left with the salt behind, okay? So that is one way of of physically separating substances. A real common one that we also saw in yesterday's simulation was the pitcher, the water filter pitcher. Now, at the top is where you add your regular water, whether it be from the faucet, whether it be from wherever it is that you get it from. Now, If you want a purified water, well, so what happened in that picture is that there was you would notice, you remember that there was big chunks of compounds that was not H2O that was filtered out as it passed through the charcoal or the filter. That is another way, that is another technique for physically separating particles and solutions, okay? Um, they talk about here the compound acetylsalicylic cyclic acid, which is an active ingredient in aspirin. Okay, this is a substance because it has a chemical compound that cannot be reduced by physical means. Okay, I cannot break it down because those elements are chemically bonded together. However, the aspirin itself, that contains the acid is also, you always want to remember, considered a mixture. Okay, why is it going to be considered a mixture? Well, in addition to having that pain relieving ingredient, the acetylsalicylic acid, cyclic acid, aspirin will also contain wax to make it, look nice and shiny when you pop it in, cornstarch to make sure that everything clumps together and stays together, and then maybe cellulose to help with, either dissolving rapidly in your stomach or maybe even helping it bond to certain, to into your bloodstream so that it could move, so it can remove the pain faster. Okay, these added materials bind the tablet components into a solid pill and will influence how fast it will dissolve in your stomach. Substances may be either elements or compounds. Okay, so you'll start by identifying something or your unknown as a pure substance or a mixture. Okay, it's always those two options, pure substance or a mixture. Now, once you have decided that it is a pure substance, there are two categories that pure substance can fall into. One is an element, the other is a compound. Okay. Elements you have to remember are anything on the periodic table: hydrogen, oxygen, nitrogen, chlorine, argon, iodine, titanium, gold. All of those are examples of elements. Pure compounds are like carbon dioxide, CO2, water, H2O, sugar, CH, C6H12O6. All of those are examples of compounds. Now, the easiest way to always remember the difference between a compound and an element, well, compounds will always have more than one element, okay? And we identify elements by the capital letter at the front of, the capital letter in, the formulas, okay? So if there's more than one capital letter, that's how you know that there's more than one element in, and it's considered a compound. These substances can also be solids, liquids, or gas. For example, silver will exist in solid form. Mercury will exist as a liquid at room temperature. And then helium and radon will be gases at room temperature. Compounds like water can take all of those three, can change into all three of those states: solid, liquid, and gas, depending on the temperature. Okay. A substance, let's summarize our lesson for the day. A substance is a pure material with a uniform and definite composition. A substance cannot be separated into components using physical means. A substance can be a solid, a liquid, or a gas depending on the temperature. Now, this is your assignment for the day. The review questions: number 1, define a substance; number 2, can salt be a substance; and number 3, is aspirin a substance? Okay, get these into me as soon as you can. If there's also, a physical chemical change worksheet. Now, this, if you do page 1, you will get two free hundreds on last Thursday and Friday's, work, because I know they were really tough. I went through it really quick, and I haven't gotten a lot of, responses as far as the work. So what I'm going to do is I'm going to substitute Thursday and Friday for these two for this worksheet. Okay, there is 2 pages, but that second page is for my pre-AP. Okay, so if you're pre-AP, you're going to do both pages. If you are a regular student in my class, you'll only do the first one. Okay, let me know if you have any trouble with this. My suggestion, if you're just doing the front, you should be able to use Google Docs, no problem. If you're working on the back pre-peers, I would use Cami because some of these are boxes. They're not, I didn't create them, okay? I kind of cut and paste. So try your best, turn it in as soon as you can, and we will see you tomorrow. Again, sorry that I'm posting this really late.